Okay, now we have both HC and HO. Remember, HC and HO themselves don't actually matter. What matters is the difference between the two, because the difference between HC and HO is equivalent to the difference between your assumed position and your true position, or the position that lies on your line of position, because that's the only reason they're different. The only reason the height of the sun would be different for your HO than from your HC is if you were a certain distance away from your assumed position along the azimuth here. The difference away being equivalent to the difference the difference between the HC and HO, because arc and distance are the same thing. So now, and this is pretty easy, we have to compare HC and HO, find the difference between the two, which will be called our intercept, which is notated with a lowercase a. And the mnemonic to remember how to do it, because you have to find essentially if it's positive or negative, though we don't say positive and negative, we say towards or away, is the mnemonic. There are two of them. One is HO, MO, TO, homo-to. Think of it like you can think of SOHCAHTOA for trigonometry, just homo-to, which means HO more towards. So if your HO is higher than your HC, you label your answer towards. If your HC is higher, then you label it away, because that's the opposite. The other one you could remember is CGA. That was really bad. CGA. You could think of it as Coast Guard Academy. In that case, computed greater away. HO greater towards, computed greater away means the same thing. I always remembered a homo-to, but you can remember Coast Guard Academy if you like. Now we actually do the calculations. So I usually write it just beneath, I rewrite my HC just beneath my HO, just because there's room for it here. HC is 65 degrees, 14.8 minutes. You can see it's, you need to use your corrected HC, not your original HC. So now that we have the two next to one another, we just subtract the two and find the difference. So we've got 65 degrees, 14.6 minutes, and 65 degrees, 14.8 minutes. They're incredibly close in this case. They're not normally this close. This doesn't mean you were more accurate. This just means that you happen to be really close to your assumed position. It's a matter of luck, nothing else. So we don't even need the calculator. You know that the difference between the two is 0.2 minutes. But now you need this labeled correctly. Is this a towards and away or away? Well, HO more towards. HO is 14.6. HC is 14.8. So HC is greater. Homo towards, CGA, Coast Guard away. Meaning Coast Guard, the HC is greater, so we use away. And now that we have this, we officially have everything we need to plot with, but it's really good to rewrite it all off to the side so we can clearly compile the information. And the 4 bits of information you need when you plot are your assumed latitude, your assumed longitude, your azimuth, and your intercept. Oh, sorry. So I'm going to write those 4 pieces up here. I'm going to write assumed latitude, assumed longitude, ZN for azimuth, and A for intercept. So our assumed latitude is 19 degrees north. So we write 19 degrees north. Our assumed longitude is 108 degrees, 7 minutes west. 108 degrees, 07.0 minutes west. Our azimuth is 104.4 degrees. Azimuth 100.4 degrees. And our intercept is 0.2 away. 0.2 away. I made a note not to a point not to include the unit here because technically the unit is minutes. However, if you want, you could also just write 0.2 nautical miles. Because remember, a minute of arc, especially a minute of latitude, but we're working in perfect terms here. So any minute of arc is equivalent to a nautical mile. So this difference in arc of 0.2 minutes is the same as a difference in distance of 0.2 nautical miles. So you could write your intercept either way, because when we plot, it's going to be treated as a distance of 0.2 nautical miles. Whichever one you prefer to use as your unit, either is fine. So that's how we get our intercept after comparing HO and HC. And then once you've done all that, you write your information in the little box off to the side so that you can use it to plot with. We're going to do the same for the next problem. So step 1, here's our HO. We're going to carry over HC so we can compare the two. So we write HC immediately beneath HO. And when HC is 25 degrees, 22.9 minutes. And now we've got 26 degrees, 07.8 minutes, 25 degrees, 22.9 minutes. And we compare the two. So to take the difference between the two, I'm going to add 60 to 7.8 so that we can cancel out the degrees. 60 plus 7.8 gets 67.8. Then we subtract 22.9 and we get 44.9. So our A is 44.9 minutes. Now we have to see if it's towards or away. Let's see. HO is greater than HC. So we write out HO, MO, TO, or CGA. HO is greater than HC, meaning towards. So we label it as towards. Now that we have that, once again, off in the corner, we can label assume latitude, assume longitude, ZN, and A. Assumed latitude for this problem is 27 degrees south. 27 degrees south. Assumed longitude is 122 degrees, 16.1 minutes west. I forgot to label that as west when we were doing the work, but remember to always put that there. So 122, 16.1 minutes west. Our ZN is 044.2 degrees. 044.2 degrees true. Not that it would ever be magnetic, but it's important. You should still label it true just in case. And our A is 44.9 minutes or nautical miles. I'm going to do minutes towards. It's a little blurry. There we go. 44.9 minutes towards. Again, it's the same as nautical miles. Final problem. We start by calculating A. So here's HO. HC is 44 degrees, 29.3 minutes. And we do 35. Here's A. We do 35.9 minus 29.3. So 35.9 minus 29.3 gets 6.6 minutes towards or away. HO, MO, TO. HO is greater than HC, so this is also towards. Now that we've done that, we can come off to the side here, write our assumed latitude, our assumed longitude, our ZN, and our A. Assumed latitude is 23 degrees south. Assumed longitude, I again forgot to label it, but it is in the east. 78 degrees, 26.3. So 078 degrees, 26.3 minutes east so you don't get confused. Our Zn is 095.8 degrees true. And our A is 6.6 minutes towards. And there's our final information. And these four numbers here, this is the whole point of all of the work you just did. All of this is only for this exclusive goal, the singular goal of getting these four numbers. Because what you can do with these four numbers, if we come back to our diagram here, if I can ever find it. Here we go. Next page. God damn it. Next page. If you look, here's our assumed latitude. Here's our assumed longitude. Here's our azimuth that's passing through the assumed latitude or the assumed position at this angle. And then this distance here is A. And if the distance was going this way, it would be A over here. So now that we've found these four values, we can plot it down on our plotting sheet as a specific point, which is the assumed latitude and longitude, a bearing off of that point, which is our azimuth, and then a distance along that bearing, which is our intercept. And once we find the point that's that distance along that bearing, we set a perpendicular line, and that will be our line of position. So now that we have these four numbers, we can actually plot an LOP after all of this effort.